So last week we looked at ionic and covalent bonding. This week we'll also look at metallic bonding. So when it was ionic, you had a metal and a non-metal. Covalent, you had non-metals only. And then metallic, you're going to have metals only. So something like iron by itself, or copper by itself, or sodium by itself, metal only, it would be metallic. And when we're describing what metallic bonds are, it's actually quite similar to ionic in terms of the words that we use. We had an electrostatic force in ionic, we've still got an electrostatic force in metallic, okay? Electrostatic, not electromagnetic. But the difference is what that force is between. In ionic, it was between oppositely charged ions. Metallic, the electrostatic force is between a positive ion, so something positive, and delocalized electrons. So you still have the force between something positive, the ion, and something negative, the electron. Over here, the positive thing was an ion, and the negative thing was an ion, but over here the negative thing is an electron. Now, we saw with ionic bonding that the electrostatic force was strong. This is still true for metallic bonding. Electrostatic force is always strong. The only weak force is intermolecular. So if we've got a strong force, what do we expect the melting point and boiling point to be? Do we expect metals to be solids, liquids, or gases at room temperature? Alright, so if there's a strong force, we know that the particles are going to be attracted to each other, and that means they're going to be close together. And if they are close together, metals are going to be solid at room temperature. Also, because that force is going to be really hard to break, they're going to have high melting points and high boiling points. Okay, so similar to what we saw with ionic bonding. The other property we need to look at is, can metals conduct electricity? And when we were looking at this last week, we said in order to conduct electricity, a substance needs charged particles that are free to move. And I told you there were two types of charged particles. You have delocalized electrons and you have ions. Now, metals have both. They've got ions and they have delocalized electrons. But you want the one that's always free to move. And in metals, even when solid, those delocalized electrons are able to move freely. So we're not going to talk about the ions, we're only going to talk about the delocalized electrons. And we're going to say that metals conduct electricity because of the delocalized electrons, even when they're solid. Okay? The rest of the questions are the same, are on the content that we went through last week. The last little thing I want to highlight is there's a question asking you to identify a substance based on their properties. So it's important that you can kind of summarize the properties. So MP and BP is just melting point and boiling point. If a substance is ionic and it's got strong electrostatic forces of attraction, I would expect that melting and boiling point to be high. Okay, remember room temperature is 25 degrees, so I'm expecting it to be considerably higher than room temperature. Simple covalents, they've got weak intermolecular forces. If they've got weak forces, then the melting and boiling point will be low. And we've just seen metallic has the same strong electrostatic force as ionic, so again, I'm expecting that to be high. Conducting electricity, they have to have charged particles that move freely. Ionic compounds have ions. Okay, they do have ions, but those ions can only move when liquid or aqueous. Okay, when the ions are held in a solid, they cannot move freely. And what this means is that ionic substances do conduct when they're liquid and aqueous because the ions move, but they don't conduct when the substance is a solid. Okay, so you have to melt it or dissolve it in water before it can conduct electricity. Simple covalent, they don't have any free moving charged particles. That's just a flat out no, they don't conduct electricity, they never do. Metallic, they get just a straight up yes. Okay, you don't need to melt them, you don't need to dissolve them in water. Their delocalized electrons means that they can always conduct electricity even when they are solid. So I just give you an example of one of the questions. It talks to you here about rubidium bromide, okay, and it shows you a bit of the structure. Rubidium is a metal and bromine is a non-metal. So I know straight away that this is going to be ionic. And if it's ionic, I need to come down here and pick a melting point and boiling point. Now, I know ionic means high. 6 degrees isn't high, okay? Then I've got 69, another 69, a 693. Okay, I'm kind of leaning towards 693 here. That's properly high. Over here, boiling point, what would I expect the boiling point to be? The boiling point should be super high. It's an ionic substance, so it should be really high. So I'm just gonna come right down here, and I'm gonna go for the highest. A melting point of 693 and a boiling point of 1340. So a super high melting and boiling point because it is an ionic substance.